Lesson 8-7, Linear Inequalities, Part 2. All right, reviewing really quick what we learned in the first part of 8-7, we learned how to graph an inequality. So if we had an inequality like y is greater than 2x plus 1, to graph it, we made it an equation temporarily, used our y-intercept and our slope to graph the line. Oops, and because it's a greater than sign, I should have made my line dotted. So we use dashed lines when we have a greater than or less than sign, and we use solid lines when we have greater than or equal to or less than or equal to. So dashed for the first two. All right, then once you have it graphed, we picked a point, whichever side, as long as it wasn't part of the line, and if that was a solution in our inequality, then we shaded that side of the graph to show all of the solutions. All right, so with that, remember when we had a system, oops, I need to be in a pen, a system of equations? That's when we had two equations like y equals 2x plus 1 and y equals x. To find their solution, we graphed them on a coordinate plane, we graphed the two lines, and looked for their intersection point. All right, so in this lesson, we now have a system of linear inequalities. So when we graph an inequality, remember that we shade all the solutions? Well, now if we graph two, there might be two shaded regions. We're looking for the shaded region that they both share. Let me show you how we do this. All right, so a system of linear equalities is when you have two or more linear inequalities. It's the same thing as a system of linear equations, just now we have an inequality symbol. All right, so when you're given these, you want to graph them both. So y is greater than negative x plus 1. Start with that. I'm going to look at it as y equals negative x plus 1. Y-intercept of 1 and my slope of down 1 over 1. All right, that is a dotted line because of the greater than symbol. So I'm going to draw my dotted line. So there's my first line. Now, after we graph an inequality, we usually find out which side we shade. You're going to do that with these two when you have a system. I'm going to use 0, 0 as a point because it isn't part of my graph or my line. If I put 0 in for y, oops, 0 should be greater than, negative 0 is just 0 plus 1. Is 0 bigger than 1? No, it is not. So with this line, I'm going to be shading this side. I'm just going to mark it right now. If you want to lightly shade with your pencil, that would work. I'll show you why you want to do it lightly. Okay, so this side of my line. Now it's time to graph my second inequality. Y is less than x plus 6. Well, I'm going to look at it as y equals x plus 6. Y-intercept of 6, 1, 2, 3, 4, 5, 6. Slope of up 1 over 1. All right. Now that is also a dashed line. I have to look at my inequality symbol. So if I make my line like this, I can extend my first line a little bit further too. There we go. Okay, so I just graphed my second line. Where do I need to shade? Well, I'm going to use 0, 0 again. 0 equals 0 plus 6. Oh, sorry. Is 0 less than 6? Yes, it is. So I'm shading the side that 0 is on, which means everything on this side of my line. So we have two shaded regions. One in purple was all of this. One in green is all down here. The only part that they share is this side, so where the purple and the green both blend. This region are all solutions to both of these inequalities. Let me do another example. So solve the system. They gave you two inequalities by graphing. So first I have y equals negative 2x minus 5. Go down 5. A slope of negative 2 is down 2 over 1. Up 2 over 1. And that is a solid line because of the greater or less than or equal to symbol. So I'm going to make a solid line. And now which side would I shade? Well, let me put 0, 0 in. Is 0 less than or equal to negative 2 times 0 is 0 minus 5. Is 0 less than negative 5? No, it is not. So I would shade this side of my line. All right, time to graph the second. Y is less than half x. Pretend it's an equal sign. My y-intercept is 0 because there isn't anything. Slope is up 1 over 2. Up 1 over 2. Down 1 over 2. So I can see where they intersect, but with inequalities, the intersection point isn't what we're looking for. All right, I need a solid line again, going through my points. What side would I shade? Is 0 less than 0? Is 0 less than 0? If this was an equal to sign, this would make sense. But 0 is not less than 0. So I'm not going to shade, oh, I can't use 0, 0 because my line goes through 0, 0. Don't do that point. Let's rewrite my equation. Let's use a different point. How about negative 1, 1? So x is negative 1 and y is 1. Is 1 less than negative half? Well, no, 1 is greater. So I'm actually shading everything on this side of my line. Look for what's in common. So your answer to these is really the shaded region. So with a dark pencil, you would shade the region where there's green and red. So this area is the solution to my system of inequalities. Go back and rewatch those examples if it was a little unclear. You have one example to try on your own. Using graph paper, solve the system of inequalities right here by graphing. Shade the region that they both have in common. Good luck!